Hi guys, Marketa here. Today we're going to be looking at linear modelling and in particular at two different types of linear modelling that we will commonly come across. So here are two problems. Sally has a plant which grows at a rate of 3 millimetres per week. The plant is 7 centimetres high to begin with. How tall will the plant be in a year? The second one is where Meg has a plant, and this plant is 7 centimetres high after 2 weeks and 15 centimetres high after 6 weeks. How tall will the plant be in a year? So both questions are asking us to find how tall the plant will be in a year. Both questions involve linear modelling, but they are different. This question, with Sally, gives us the rate of 3 millimetres per week. It also tells us what the plant was to begin with, and that's 7 centimetres high. This I will refer to as type 1. They give us M, i.e. the gradient, and C straight away. M in this case is 3 millimetres per week, so it's the rate at which the plant changes or grows, and C is the constant, something that was there to begin with. That's the 7 centimetres high, because that's how tall the plant was to begin with it. I'm going to call that type 1. In the second type, we're told the plant is 7 centimetres high after 2 weeks and 15 centimetres high after 6 weeks. I'm going to call this type 2. Here we're given 2 points that we need to work with. The best thing to do is to identify which of these two types of modelling problems you're dealing with, and then you can go about solving the problem. Let's try some. Let's solve the situation for Sally. Step 1, we would state the general equation, which is y equals mx plus c. Step 2, we would want to make a specific equation. First of all, we know that m is something to do with 3 millimetres per week, and that c is going to be 7 centimetres high. So we could say y equals 3x plus 70. I've used 70 here. Think about why that could be. If I want to put h in millimetres, I have to put 70 for the 7 centimetres high, because 7 centimetres is 70 millimetres. I can't have different units within the same problem or the same equation. So in that case, I'm saying the height in millimetres is equal to 3 times x plus 70. I'm going to change, or I could say, if I wanted in centimetres, the height in centimetres is equal to 0.3 times t, being the time, plus 7. In the millimetres one, I could have used t for time as well, instead of x. It doesn't matter. Now, the next thing you want to do, now that you have your equation, is to substitute to solve. Once again, the rate being 3 millimetres per week and 7 centimetres high to begin with, there's our equation. There's the equation I'm going to use. Height in centimetres is 0.3t plus 7. You could have used the one for millimetres. As long as your units are the same, it doesn't matter which. Let's substitute 52, because 1 year is 52 weeks. 0.3 times 52 plus 7. Notice that 3 millimetres per week, or 0.3 centimetres per week, must be the same units as when I substitute in 52 weeks. I couldn't substitute in 1 for 1 year. That wouldn't make sense. My units once again needs to be the same. By solving, I end up with h in centimetres is 22.6. Finally, you want to answer the question in sentence form. This is really important. Sally's plant will be 22.6 centimetres high after a year. You would highlight this or circle it to show that this is the final answer after all that working out. So that's type 1 of the linear modelling questions. Let's move on to the second one, which, as we said, was type 2. Meg has a plant which is 7 centimetres high after 2 weeks and 15 centimetres high after 6 weeks. How tall is Meg's plant going to be in the year? So first of all, I'm going to state the general equation again, being y equals mx plus c. I'm going to identify 2 points. Now here we have to be careful. Think about what x will be and what y will be. X refers to the independent variable. So the time in this case is going to be the independent variable, because how high the plant grows depends on the time. So one of my points will be 2, 7, because 2 weeks and 7 centimetres, and the other will be 6, 15, because 6 weeks and 15 centimetres. I'm going to use these points to solve for m. Remember the gradient formula? M equals y2 minus y1 over x2 minus x1. I substitute in 15 minus 7 over 6 minus 2. I end up with 8 over 4, which equals 2. So far I've got y equals 2x plus c. I've solved for m. I have not yet solved for c. I need two pieces of information to form a linear equation, m or gradient and c or y-intercept. Let's now solve for c. So we've got y equals 2x plus c. Let's sub in a point. We know that when x is 2, y is 7. So therefore we can just put them into the equation. 7 equals 2 times 2 plus c. 7 equals 4 plus c, and therefore c equals 3. So now I've got both pieces of information. Y equals 2x plus 3. I'm going to put that into a specific form. H in centimetres, and this time I'm not using millimetres because my question does not deal with millimetres at all. So there's no need to convert to millimetres. So height in centimetres is equal to 2t plus 3, where t is the time in weeks. Let's substitute to solve. Once again, we're looking for a year, and a year is 52 weeks. I can't substitute 1 into t because t is in weeks. I need to substitute in 52. H centimetres equals 2 times 52 plus 3, which equals 107 centimetres. Again, I use a sentence to answer the question, and this is what I highlight or circle as my final answer. Meg's plant will be 107 centimetres in a year. And that's the end of linear modelling for today.